All right, so difference of squares. What we're talking about here is pretty much the opposite of what you see for this warm-up. So we're going to FOIL, and we are going to distribute the x squared minus 4x, and then distribute the 4 plus 4x minus 16. You notice that those two middle terms will cancel out, and we'll be left with x squared minus 16. So this is the difference of squares that you saw yesterday. So the following rule is also what you saw, Monday, not yesterday. So we'll do the square root of a and the square root of b. And as long as the minus and plus are different, you're good. It doesn't matter which one comes first, the plus or the minus. Either way, that middle term will cancel out. So this is just more practice on difference of squares. You can see the video on Monday if you really need more work on this, but I want to show you some of the tricky ones. So like number 3, all of the other ones that you've seen before, the x squared came first. Well, for number 3, it is the exact same process. So you square root whatever goes in the first blank, and the square root of that goes in the first blank. So the square root of 81 is 9, so we put 9 in the first blank. The square root of x squared is x, so we put x in the second blank. Minus, plus, you can FOIL it out, it still works. So be very careful with that. Don't think it's prime or something like that just because they flipped them. It is not. However, number 5, you notice the title of this is difference of squares, right? In other words, so we have two perfect squares and we are subtracting them. Well, number 5 has a plus sign. It has an addition sign. So this is considered prime. That is not a difference of squares, and you cannot solve that. All right, for number 6, same sort of thing. The variable's at the end, but that's perfectly fine. Also, the square root of 1 is just 1, so that's a really easy one. And then we have minus 7y and plus 7y, and that will be perfectly fine there. Sometimes I can get to do two different variables, like for number 10, the square root of x squared is just x, the square root of 81y squared is 9y. So really an easy concept once you continue to keep working at it and you see the pattern. Really not bad at all. You just got to know your perfect squares. All right, for number 13, we can do the same thing. The square root of this one is just going to be 2 variables. So the square root of x squared, y squared is going to be xy. Square root of 1 is 1, and you put your plus and minus signs. Okay. Very rarely will they give you something like number 15, where I think this is a typo. I think that 5 should be a 9 or something like that. But you can just leave that as 2c minus the square root of 5d. And then 2c plus the square root of 5d. Because that is not a perfect square, you can just leave it as a square root of 5. But honestly, I would just change that to a 9 to make it simple and call that a 3. And that'll make things a lot easier. Not sure if that was a mistake or a typo or what. Also, sometimes they'll start to throw bigger numbers in. They're not just going to have x squared, they're going to have something to the 6th or something to the 8th or something like that, or 4th. So anytime you have that, anytime you take the square root of a variable like that, you are just taking half of the exponent. So that will be k to the 3rd power over here, minus 4, and k to the 3rd power plus 4. Right, so when I multiply that out, you're going to add the exponents. That'll get you back to 6. So if I had something like 18, and I square rooted this one, which is p to the 4th power, that will be p to the 2nd. So you just take half of whatever exponent it is. And then they're going to give you some with a GCF. So be very careful with these. I'll do some of the difficult ones. 24. Our GCF there is a 5. Q. We do have a Q in both of them, right? So we have a Q present in both of them, so we take the smallest one. So that will be 5Q with an open parentheses. Now we just divide 9Q squared minus 4. Now, we're not finished. That was just the GCF. The remainder that we see right here is a difference of squares. So we will take the square root of the first term and put that in the first blanks. So that is 3Q. And the second term is going to be a minus 2 and a plus 2. Sorry for that not looking too great. Let's see here. I'll do a couple more with you guys. I'll do 28, 29, and 32. How's that? So, looking for a GCF. The number is 4 here, and we'll do a y as well. We can't take out an x because there's not an x in both of them. So we simplify this out, and that'll leave us with 2x squared minus, and then 32 divided by 4 would be 8. Oh, wow, it's 8. It's not 4. Man, I'm losing it a little bit. Both of them can be divided by 8y. So 8y is our GCF, and we'll have x squared minus 4y squared. There we go. And then we have another difference of squares. X goes in the first, 2y goes in the second, minus plus. Minus plus, plus minus, doesn't matter. Here we have 9p as our GCF. 9p with an open parentheses. It's really important to write this step. Some students say, hey, I can just skip on to the next step. I do not want you to do this. I want you to write it just how I am, because when you say, hey, I already know what it's going to be, you're going to forget and you're going to actually accidentally put p instead of 2p, or, a 3 instead of a 1 or something like that. It's just much easier to go ahead and write out that extra step and make sure you know what you're talking about. Make sure you don't make any careless mistakes, even though you do know what you're talking about. So mn is our GCF here. We don't have any numbers, but that's perfectly fine. M squared minus 1. Make sure you put that 1 there. Mn divided by mn does not cancel out to nothing. It cancels out to 1. So now we have mn, 2 open parentheses, m in the first blanks, 1 in the second blanks, plus minus, minus plus, doesn't matter. So if you guys got any questions, feel free to shoot me an email.